So my name is Alex, and this presentation will be about confused deputy problem for databases. I can hardly see all of you, but that's fine. So couple housekeeping things. Slides will be available like always. And second thing is that this presentation will have two parts. So I will take questions after each part to make sure that you all understand and on the same page. All right, so let's begin. So again, my name is Alex. I've been working with MySQL for a long time. I started at MySQL AB, the company behind MySQL, 2006. And I worked at Sun Microsystems after acquisition and Oracle. And then I worked at Percona as well, which is the database consulting company. And my interest in security, offensive security, started with playing capture the flag games. And I joined Amazon Web Services about 3 years ago, and I'm currently leading RDS Red Team, a security and penetration testing team at Relational Database as a Service at AWS. So let's start with this. What is the confused deputy problem? So the confused deputy, as Wikipedia say, it's a computer program that is tricked by another program into doing something that can lead to the privilege escalation, right? Misusing its authority on the system. So to understand it better, let's start with example on Linux. So imagine that we have this handy cron job created by the system administrator to make sure that all the files in a user home directory are actually owned by that user, right? So that's pretty legitimate, right? So if a root user will upload the file into the directory, into the home directory of the user, that's not good. This user may not be able to use it at all. So we created this handy cron tab, which will find the files, all the files in the user home directory, and shown it to the owner of this home directory. So what could go wrong? To understand that, I recorded this screencast, and I'm going to play that. So let's say that we have this cron job here, right? And there are two parts of that, right? The root part and EC2 user part. So here, as a root, I put a file in a home directory of my user, and I'm just waiting until the cron job will fire up and fix that. So the owner is now root, and the cron tab will fire up and change the owner of the file to EC2 user, which is what is supposed to happen. Right now, we can see that just happened. But now our user is super smart, and the user figure out how they can abuse the privilege. So created a symlink to etc password. So now what will happen? The cron job will run, and it will actually follow the symlink. By following the symlink, it will show the etc password file to the user. So let's wait for a second. It will fire up in a minute. So not yet. etc password is still owned by root user, which is supposed to do. In a second, give it another 5, 10 seconds. Hopefully it will work. Right. So now the etc password is owned by EC2 user, and our EC2 user is free to modify EC2 etc password and create its own root user. So now I can change this, I can create another root 2 user, or I can simply change my UID to 0, and that's it. So this is the example of the confused deputy problem, where we have a legitimate program for legitimate purposes, and we abused it without knowing it. It will show the file to our user, which it is not supposed to do. So now let's look at the databases, how the databases usually work. In the database space, we have database super user, usually, right? A root user, which have all access to the whole database. The database name is ambiguous. Usually, people think about the database as an instance or database as a schema, right? In this case, we have a user which has a certain privileges, and these certain privileges are limited to their tables. And this user DB really means user schema here, right? So the goal of the unprivileged user is to get a super user privileges on the database. So instead of having an access to a specific set of tables, they want to get the access to all and every table on the database. So now, how do we do that? How we can apply the confused deputy problem to the database? Basically, the idea is super simple. We create a poisoned database object. Then we will trick the super user of the database to run it. And then, because we have a poisoned object, it will change the database privileges to the super user. So now, what are the database objects? And I think people are confused. People think about the database as data only. But it's really not the case, right? So we know how dangerous it is to mix data and code. But in reality, inside the database, there are lots of code. So there are lots of code that lives inside the database. There are stored procedures, there's functions, triggers, events. Depending upon the database, there can be all sorts of stuff. And the most interesting part is that we think about database, relational databases, SQL, right? There are functions that are written in SQL or PL/SQL. But there are functions in some databases that can be written in C, in Perl, in Python, anything, right? So it's really, really the code. So let's take a look at a couple examples here. So we have a function privilege escalation. And this is on Postgres. So this function, the only thing that this function does is that it will alter the user to super user. And if non-super user will try to run this function, it will say, I cannot do that, right? Must be a super user to alter super user role. But what if a super user will run it? Right? So again, unprivileged user cannot escalate their privilege to more than they already have. In MySQL, this is a MySQL notation. So I created a privilege escalation function which will grant all privilege to the super secret database schema. And if I try to run it, then I will say access denied. But again, what if the super user will run this? Can we trick the super user to do that? So we will have two examples now. The first is shorter about the Postgres, and the second is longer. Second is a case study on MySQL. But before we'll go there, are there any questions? All right. So let's go with start with Postgres. So Postgres is interesting. Postgres has schemas which are similar to OS directories, and Postgres have public schema. So if you think about the public schema, you think you can create a read-only user in Postgres? Not necessarily. You create a user in Postgres, and they still be able to write to a public schema, unless you specifically change the configuration to deny that. So public schema is also very interesting. And similar to path on Linux, there is a search path on PostgreSQL. So this is actually a very well-known security issue, attack technique. Right? This has been filed as CVE 2018. You can poison the search path. So the goal of poisoning the search path is to confuse the super user to execute your function. So let's take a look at this. So we have these operators, right? Plus, minus, whatever, is an operator in Postgres. And in Postgres, you can actually overload that. So you can create your own addition operator. Right? So to illustrate that, I created my own operator in a public schema. And this operator will always return 42, because it's actually the answer. Right? So I overloaded my operator and see what happens. So if I do select 1 plus 1, it will give me the right answer. But if I do select 1 plus 1.0, it will give me 42. So anyone can guess why? Is it kind of joke? Why it happened? Why did, so we know we know that we have overloaded the operator. But why did it worked with 1 plus 1, and it worked differently 1 plus 1.0? Any guesses? Yes. Exactly. So the second parameter is float. So in Postgres, that's different. The function only makes sense depending upon the type of the parameters that is passing to it. So this one will match the standard operator. And this one didn't match the standard operator. And because the search path is defined as user, public, it will not find this operator in user schema. And it will indeed find it in the public schema. Right? So let's go back for a second. Here we can see int float, right? So that's why. How do we use that for our privilege escalation? And to illustrate that, my colleague, Martin, who is not here, has recorded a video. So let's take a look. Will it work? All right. So again, we have our table. We have our function. Inside of that function, we want to retrieve the password. If you try to retrieve the password being let me go back. Let me go back first. Maybe go back for a second, sorry. All right. So if you want to retrieve a password in PostgreSQL and you're not super user, you will not be able to do that. Right? So I created a function, and inside of that function, I'm trying to select the password. So now I overloaded the operator. I created my operator in the public schema. And now, instead of unprivileged user, I connect with a super user. And we see the hash sign. So that's super user. So now the super user will simply do some sort of addition, right? And the additions will go into our table that we have created beforehand. So we have nothing here. And now we're trying to do insert into select. So now I do select 1 plus 2, 2.0. That is float. That will choose the poisoned function, and then we got the password. So we retrieve the password for the, what is it, super user, Postgres user, right? So now we can try to crack that password, or much easier approach, we can just put alter user super user inside of that addition function and get the super user right away. All right, so that's the end of the Postgres example. Any questions? All right, I can hardly see, but I assume there are no questions. All right, so let's do the case study for MySQL. So here's the case study. Here's the sample architecture. Imagine that we have a database, and we have a healthcare company, which stores the health records in a database. But they also want to run a WordPress website. And they have MySQL database, and because they have a single MySQL database, they put the WordPress database as a separate database inside the same database instance. So we all know WordPress. So our hacker has been able to connect through the SQL injection, probably, to the WordPress database. Now, this guy have full access to the WordPress. But there is nothing interesting there. It's just a website. It's just general information about this healthcare company. So now the goal is to get to the health records database. So the question is, can we get here? Right? So this is the isolation, right? The boundary. We're trying to break the boundary inside the database, break the boundary from one database to another database using the confused deputy problem. How can we do that? So let's take a look what we have in the database, inside the MySQL database here, right? So let's take a look at the list of users. We have admin user, that's a super user that has all access to the whole databases. We have the dedicated WordPress user, which only have an access to the WordPress database. And we have a health data service user, which have full access to the health records, right? But look, we have something else. We have a monitor user. And this monitor user is not a default user. That's a custom configuration, right? So the question is, what is this user? We want to explore first and see what is there. So we have an isolation between the databases. The WordPress user only have privileges to the WordPress database. Health service user obviously has all privileges to the health data service database, right? And then we have a monitor user. A monitor user have select reload on everything. So this is unprivileged user, but at the same time, this unprivileged user have an access to all the databases inside this MySQL instance. All right. So this is a performance monitoring system. And this performance monitoring system will require you to create a user which have a global select. And they also decided to add execute here. So the question is, can we confuse the performance monitoring system into privilege escalation? So MySQL is also interesting in a different way compared to Postgres. MySQL store privileges and users into the MySQL schema in a MySQL.user table. So this WordPress user, if they try to retrieve the password from that MySQL.user, they will have access denied, which is expected. But the monitoring user will have the ability to retrieve any password, hash of the password from it, right? So what does the database performance monitoring do? Basically, the goal of the performance monitoring is to collect database metrics, collect slow queries, and generate explain plan. And the database administrator will do the similar work. So they will look at the database metrics, they will also look at the slow queries, and they will try to actually run explain command on the slow queries to understand why the select query, usually select query, right, is slow. So let's take a look. This is the example of the explain plan in MySQL. So a database administrator may take a look at this query and try to determine why it's slow, so they will run explain on that. So the question is, will running explain plan re-execute this query? And it should not, right? The problem is, in some cases, in MySQL, you run explain plan and it will re-execute the query. That has been known for a long time. There is a blog post from 2020 explaining the situation and explaining why. In essence, explain plan will need to know how many rows it needs to scan. To do that, it will need to really materialize, execute the subquery. Because look at this query, right? If we don't execute the select sleep part, we will never know how many rows it will need to scan. So what will happen is that this query will re-execute, the explain plan here will re-execute the select query. And this is really bad for multiple purposes, for multiple reasons, including security. So how would we escalate our privilege? What we will try to do is to get the slow query and run explain. And we will try to actually confuse the monitoring system to do this. So remember, attacker can get tables, functions, and create any object on the WordPress. This is how this has been configured, right? You have a user that has full access to the WordPress database and only the WordPress database. So now what we'll do is let's create a proof of concept. So we will create a function, again, similar to the function that we used for Postgres, right? We'll create a function called exploit. And we will need to make that function slow. So we will check the current user. If the current user is monitor, we will execute our payload. If the current user is not monitor, we'll just sleep. So normally, it should be slow query, right? But if the monitor user will execute it, we will run the payload. And again, monitor user has global select. That's the reason why it all works. So the question is, how do we get the password back? We can retrieve it, but how do we save it? The thing is, in MySQL and in Postgres as well, you can create functions and specify the definer. So definer is like suid bit on Linux. You can specify the definer function, and definer is whatever user we specify will be used as a security context. So in this case, we specify the definer as our user, which have all access to the WordPress database. And this is how we can save our password. Right? So we create a function called save, and we will take the argument, and we will insert that text into our table to materialize that. Right? So now, the databases also have this modifier called invoker or definer. So if you specify that the SQL security is invoker, that means that the privileges to the user who runs that apply. So we create a function exploit. Inside of that, we select the password, authentication string in MySQL, and then we'll save it in our table using another function. Because we specify security invoker, that means that whoever runs that will use their own privileges. In this case, we hope that our monitoring system will run it. The monitoring system will have all privileges to select the password. It will retrieve the password and pass it to our function. Our function runs with a different set of privileges. It will have all access to the WordPress database. And this is how we get the password. Right? So now let's look at the demo. So here I have the function set up. And I have two parts here, right? Like a hacker, bad actor on one side, and MySQL DBA on another side. So the goal of our hacker is to trick the MySQL DBA to run the exploit command and get the password. So let's see how it will work. All right. So I have all my setup done. My user is corp WordPress user here. And I have my table set up, and it's empty. Now I run my poisoned select query. Right, so I just do select and then subselect, and subselect is my function. So this query is slow. It's 3 seconds, which is super slow in database standards. So now MySQL DBA has retrieved the query, and it's trying to figure out why this query is slow. So MySQL DBA, well, or maybe monitoring system, doesn't matter, will run the explain plan. And now this is interesting because this query it's not slow, right? But back on the hacker side, we have the password. Right? So we have retrieved the password of our monitoring user. This is the hash of the password. So what should we do next? The next will be, obviously, is trying to crack the password. So I have my hashcat here on my GPU instance, and I put my hash of the password, I remove the star, and then I will try to use the rocku txt to crack it. So let's see, maybe it will take a long time, so let's wait. Let's see how long will it take. All right, less than a second. And why? Because the password is pass. And why the password is pass? Because it's a monitoring user, right? No one cares about this. People think that this is an unprivileged user. They created a monitoring system. They registered that user, and they choose the pass. So I have, at this point, I got the MySQL monitoring user password. And now, because this monitoring user password has select all and every databases, all and every table, I can dump my health care system. All right, so to recap, database privilege escalation, right? We confuse the monitoring system or database administrator into run and explain. And then because MySQL explain actually can execute the statement, and it should not, but it does, we were able to confuse either monitoring system or database administrator to give us the password. Right? And monitoring user has global select and execute privileges. That's why this whole thing worked. So now we're able to download the health records database. So what happened here is that we used the confused deputy to break the isolation level between the database. So don't trust too much the isolation level inside the databases. Don't put your WordPress site on the same database instance that your healthcare records are, right? All right. So we got the monitoring user. That was simple password. That was another issue, right, in this case study. It was super simple password because people were thinking that this is unprivileged user. And as a result, an attacker can connect as a monitoring user and get the data. All right. So the conclusion of this presentation. Databases are complex. Lots of people don't understand that the database itself contains code. That's very important. There are functions, stored procedures, triggers, events, sometimes other things. The second point is, even a select statement can be disguised to run a code. So if you run select my function, inside of that my function can be malicious code. And then finally, there is a confused deputy problem for the databases. Usually we think about the confused deputy problem as for the access control rights and operating systems, but this problem exists for the databases as well. So a database super user can be confused into running an action and give the unprivileged user an additional privileges. And PostgreSQL can overload all the things, including the operators. All right, I think that's all. Any questions? Yes?
Are you aware of any researcher that's found a confused deputy in non-relational databases, such as Redis or Hadoop or NoSQL databases?
Yeah, so the question is there a confused deputy problem in non-relational databases like Redis or others? I'm not aware of, but I can imagine that there may be, right? So this is not This is a class of problems that I describe. I describe method for relational databases, right? So I don't know the method for non-relational databases, but the class of problems definitely exist. All right? Yes?
So what was the perceived value for Postgres in making all these operators overwrite?
So the question is, why Postgres allowed to override the operators, right? Um,
There's some advantage, a useful advantage.
That's a good question. I believe that it's just a function. Postgres has been adding a lot of functions historically. And flexibility on an object-oriented thing, right, when you can overload the function, may be helpful. I personally don't see how I would use that apart from the pen testing, but there may be some useful application for that. Yes.
So maybe a designer fell in love with everything should be an object.
Yes, that's right. Yes, everything is an object. Yeah, I agree. All right. Any other questions? All right. I think if there are no questions, then thank you very much.